So today, I thought I'd make a quick little video on the Flat Earth map. I've been playing the Flat Earth game for a little while. It's fun. It's a great challenge. But anyway, uh, my first thought, when every single time I look at a Flat Earth map, my first thought is, you've got thousands of years of people who believe the Earth is flat, and yet this is all you've got. I mean, I honestly, I can't understand it. I would have thought, with all that time, you would have had a better map, but you don't. So, we've just got to work with this. One other thing that I've noticed about flat earthers is the fact that they have an explanation, quote unquote, I suppose, for everything. You can throw anything at them and they will make up some sort of bullshit to explain it, even though it's factually incorrect and easily debunked. But one of the biggest things that they cannot explain and steer away from as much as possible are the distances on a flat Earth map. Nobody can explain the distances on a flat Earth map. So, for example, in real life, if you were to travel, say, from Perth to Brisbane over here, it's a little over 3,600 kilometres. We know this because we experience it in real life. But on the flat Earth map, it's a little over 8,500 kilometres. So that's pretty much the equivalent of driving from Perth to Brisbane, turning around and driving from Brisbane all the way back to Perth, and then turning around and driving from Perth to around about Alice Springs here in the middle. Seems like a serious waste of fuel to me. So I'd rather stick with the real life 3,600 kilometres. One of the best, not really explanations? I'll call it an explanation. One of the best ones I've heard of is the flight from Santiago to Sydney. And this was, this bloke said, he believes that Qantas, Australia's airline company, actually has faster planes than everybody else. This way, he can justify the distance over the flight time. I mean, come on. Seriously, you can't be that serious. But so, anyway, what I'm going to do in this video is basically break down your map and show you how to get pretty much almost exact distances from any 2 points in the world in any direction using this map. Simple. Yeah, it's simple. But first off, I have to sort of break up your map a little bit here. I'll at least tell you what it is. It's an Azimuthal Equidistant Map. You can break that into two and say an azimuthal. So you've got an azimuth, which is basically a bearing from any particular point. So this map, it's a North Polar Azimuthal Equidistant Map. So the point is the North Pole. If, say, you were to follow this line of longitude, this is 30 degrees. So azimuth is 30 degrees. Or, for example, say you're facing this direction. Or, for example, this line here, it's 90 degrees, assuming you're facing this direction. So your azimuth is 90 degrees. And then you've also got equidistant, which basically means equally distant. So it doesn't matter where you are in this circle. So the point, the distance from, say, this point to this point is exactly the same as, say, the distance from this point to this point. You also have your lines of longitude are exactly the same distance. So you've got an Earth with a flat Earth, say, with a diameter of 40,000 kilometres. The distance from your North Pole following this line of longitude is 20,000 k's. 10,000 k's to the equator, and say from the pole from here, following this line of longitude, is also the same. So that's it. I can't really use this map because this is the biggest one I can get, and I really want to scale it up to so that I can work with it a lot easier. Unfortunately, I can't scale this one without just turning the screen into just a big blob of pixels. So I'm going to use this one. It's also a North Polar azimuthal map, azimuthal equidistant map, and as you can see, they're pretty well the same. The only difference is I can scale this one up to whatever the hell size I like, which makes it a lot easier to work with. So on with the show, hey? So here we go. I'm using SketchUp for this because it's just incredibly basic to use, and I really couldn't think of any other way of explaining it to make it as simple as possible. Laugh all you like, I don't care, but this is really all I need to do the job. So, anyway, what we've got is your AE map, your flat earth map, whatever, and it's scaled to the point of, in real life, for example, the distance from the North Pole to the South Pole is 20,037.5 kilometres. And then we've got the North Pole to, say, Sydney, which is approximately here. That's 13,716. So we'll double check this one. 13, 17, 16. Sydney's disappeared, and there it is. I'll put that right on the pole there. Anyway, it doesn't matter. 13,752 kilometres. So I'm only out by, not much, 30, 40k, something like that. Right, so as you can see, the distances are correct, which is the whole point of an azimuthal equidistant map. You know, the distances along the azimuth are correct. Anyway, that's beside the point. Actually, that is the point. Anyway, what I'm going to do, I've added a few cities. So we've got Sydney, Perth, Tokyo, Washington, Los Angeles, Cape Town, and Santiago from memory. And then I've added the latitude and longitude. So we've got Sydney at 151.2093 east. I'm going to go around here and grab the trusty old protractor. I'm going to go from the geographic North Pole down to the 180, because 180 out of 360 is 0 degrees east. And then I'm going to come around here, and I want to go 151.2093. That is the azimuth to Sydney from the North Pole. And I'll do Perth from 0 degrees east to Perth, which is 115.8605. That's spot on Perth. And then we'll do this one. So we've got Cape Town from 180, 0 degrees east. And we want to go 18.4241. That'll work. It's going to get a little messy here. And then we've got Santiago, which is 70 degrees west. So I'm going to go 180 around this way. 70.6693. Santiago. Awesome. And I think I had another one. Cape Town, Santiago, Sydney, Perth. That'll work. And then we've got Tokyo. What's Tokyo? 180, which is 0 degrees east. And we want to go down to 139.6917 east. That line is pretty damn close to Tokyo. From the North Pole, where's 180? Here. So we've got Washington, which is 77.0369 degrees west. Washington. And One more for the fun of it. Around west to LA, which is 118 point, can't see it, 2437, 2437. Bang. So now we have the azimuth from the North Pole to all of these cities that I've marked out. Now I'm going to go, I actually have to, this is where SketchUp sucks, actually. I've got to draw a couple of little lines here to get me protractor straight. Right, that'll work. So I've got our protractor. And the latitude for Sydney is 33.8688. Southern Hemisphere, so we're going down 33.8688. That just disappeared. Oh no, it didn't. I just screwed that up. Try that again. God damn it. Right, oh, that's right. Right. Along the plane. Now I'm going down 33.8688. So from here now, I'm going to go from the pole. Now the distance from the North Pole to the South Pole is 20,037.5 kilometers, so 20037.5. Bang. So that's that one. I wonder if I can just put this. Sydney, that's good enough. Place it, I don't know, right there. And, oh crap, lost it. There it is. That seems like far too much mucking around. Let's scale this up a little bit. Yeah, this is too much mucking around, but you'll get the idea. I won't do it again. Anyway, so we've got Sydney. I can now delete this line, otherwise it's going to get way too confusing. I'm not sure what that line is. And this one and this one. Right. Now we're going to go Perth. So I'll just draw a little triangle here and get me protractor straight. So from here along the plane, Perth is 31.9505 Southern Hemisphere, so we're going down 31.9505. Distances required is 20037.5. I can now delete the Perth one. I've got to do it, otherwise I'll get confused. It's bloody easy to do. And I'll delete this one. Cape Town. So this is the only way I can get the protractor in the right angle. Right. So Cape Town is 33.9249 south. 33.9249 south. Distance 20037.5. Right. I don't need this one anymore. Santiago, here we go. That would be this line. Get me protractor. Right. 33.4489 south. 33. 33.4489 south. Distance. Oh yeah. 20037.5. Erase. Well, this is getting a little confusing. Too many damn lines. So that was Santiago. I can delete that one. I think I got all Southern Hemisphere. Yes. Right. Let's go Washington. This one to this one. Protractor. Right, Washington is 38.9072 north, so we're going up 38.9072 north. (20,037.5 kilometers). That's that. And I can delete that one. Couple more, and I'm done. Let's do LA. Bang, bang, bang. Right. LA is 34.0522 north. 34.0522 north. (20,037.5 kilometers) to 0037.5. Bang. I can delete this one now. And don't need that one anymore. Don't need that one anymore. So I've only got, yep, 2 more cities to go. Tokyo. Yeah, okay, I'll do Tokyo. I could easily skip it and you'll still get the point, but I'll still do it anyway. This one. Tokyo, 35.6895. 35.6895. Distance, 20037.5. Kilometers. If you don't like kilometers, get a calculator. Move to the southern hemisphere, maybe. I don't know. Anyway, don't want this one, and we've got one to go, and then that's it. And then I'll pause it, figure out what I'm going to do next, and then come back. I'll zoom in, you prick. Right. Looks like I may have already done that one. I have already done that one. Yep. Oh. Yep, no, I think I've got them all. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I got them all. Okay. So I'll just rotate this back around just so you can have a look at your flat Earth map again. I'll pause this. I'll do some math, maybe. Verify my lines are in the right spot. And I'll be back. Okay, back. I had to just bugger off there for a minute. My layer manager decided to disappear, and I couldn't find the damn thing. Plus, I had to try and memorize the math that I'm about to throw at you. So, anyway, as I said before, the whole point here is to try and work out distances on an AE math, because the further you go south, the further screwed up they are. So, now that I've drawn all my lines, from the center point using the latitude and longitude, I'm just going to calculate my distances. So we're going to go Sydney to Perth. Grab our trusty old protractor. Going to come up here. From here to here, 29.593. Where's my calculator? So, I have to think here. So 2 multiplied by pi, multiplied by our distance from North Pole to South Pole, which is 20037.5, multiplied by our angle that we just found, 29.593, 593, divided by 360, divided by pi, 3.1415, close enough, gives us 3,294.3 kilometres. What does reality tell us? So, the scroll wheel on this mouse just sucks ass. Perth. To Sydney. 3,296.53 kilometres. And I had 3,294.3. That's actually pretty good. Let's do another one for the fun of it. Yeah. So, I'll just wrong button, this one. We're going to calculate the distance from Sydney to Santiago. You know that flight that doesn't exist? Actually, Sydney to Santiago doesn't exist. Santiago to Sydney actually does. It's all about money and people you can fit on a plane and whatnot. But anyway, right, so we're going to draw a line there. We're going to get our angle right here. Bang, 102.043 degrees. Calculator. Here we go again. 2 multiplied by pi, 3.1415, multiplied by the diameter of our circle, your flat world, distance from North Pole to South Pole, 20037.5, multiplied by the angle that we just measured, 102.043, divided by 360 degrees in a circle, 360, equals that, and then we divide by pi again, 3.1415, equals 11,359 kilometres. What does real life give us? So, Sydney to Santiago. Well, where am I? Oh, I'll just search for it. Bugger. Oops. Santiago, Chile. That'll do. Close enough. It's right about here. 11,372 kilometres, and I had 11,359. There you go. That's how you can pretty much, roughly, and yet fairly precisely work out your distances on your flat Earth. But wait, there's just one more thing I'm just going to show you. What I'm going to have to do is just extend these lines a little bit, because, you know, we've already done our distances. What's going on there? This one doesn't want to go. So, here. Oh, come on, parallel. Anyway, 100 million kilometres. This one, same again. Doesn't matter how long these ones are. This one, oh, that's what I wanted. And this one, yeah. 2 more. That'll do. And this one, that'll do. So just so you can get a, bit of an idea on what's going on here. And what's going on here is this. Now, as you may or may not notice, that our line from the center point, following down this particular latitude and longitude, which we got correct distances from, actually lands dead smack on Sydney. This other one, was supposed to be leading to Perth, actually lands on Perth. This one here lands on Santiago. This one here lands on Cape Town. Then you've got Tokyo. Look at that, right on it. And then you've got Washington and LA. So, flat earthers, you've learned two things here. One of them is how to correctly calculate distances using your flat earth map. And the other one is your flat earth map is just a projection of the globe.